6-1, solving systems of equations by graphing. I'm going to show you what a system looks like. Now this system has how many equations? Or how many linear functions? 2. Okay? Now a system is any set of equations that has more than 2 or more equations. Now let's start with 1. I want you to focus on the y equals negative 4x for just a moment. Now, does this equation have a solution? Yes. How many solutions does this equation have? One solution? Infinite solutions. Why? Because any point on this line is a solution. In other words, I can take the coordinates of that point, plug it into this equation, and show that the left side equals the right side. For example, if I take this point, negative 1 comma 4, let's plug that in. That's your x coordinate, that's your y coordinate. So y is going to be 4 equals negative 4 times negative 1, and 4 equals 4. Okay? And you can take any point on that line and plug those values in, and you would still get, you'll see that the left side equals the right side. Now if you add a second equation, this is x plus 5, correct? Any point on this line would also be a solution of that equation. Correct? Okay. Now, what we're looking for is what would be the solution of the system of equations. So what would be, in other words, what is common to both equations? Lucy? The point of intersection. And what is the point of intersection here? It's actually negative 1 comma 4. And which are, in other words, just like we proved that this point works for y equals negative 4x, it should also work for y equals x plus 5. Let's try and do it mentally. What is y? 4. What is x? Negative 1. So 4 equals negative 1 plus 5, and you get 4 equals 4.
So there could be more than 3?
We'll talk about that.
That's when,
No, he wasn't here yesterday.
What do we...
We started this lesson yesterday, Michael. We didn't record it yesterday, so just want to record the whole thing. Okay? But that's a great question. We're going to talk about that in a minute.
Do they all have to intersect on the same point for it to be solved if there's more than 2 equations?
What do you think?
Yes. And so there can be some that aren't solved. Like that don't have
A solution?
But with 2, there's always a solution unless they're parallel.
Okay.
Isn't it 4 equals 4?
What did I say?
You said 5 equals 5.
Oh, sorry. It is 4 equals 4. Okay. This is what we just proved. Since the 2 lines intersect at negative 1 comma 4, that would be the solution of the system. And here's your proof to show that it works for y equals x plus 5. It also works for y equals negative 4x. You with me so far? Good. Let's skip that page. Let's go to this. Try and make this a little bigger. Can you all see it? Okay, good. Scientists studied the weights of two alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown below. After how many months did the alligators weigh the same amount? Now, what you don't see here is, you don't see the graph, of course, you have to graph it. But what else do you not see?
Well, you
The equations. So you have to come up with the equations. But do you think you have enough information to come up with the equations?
Yeah.
What tells you that this has to do with a system of equations? The fact that there are two alligators.
And they're going at different rates.
They're going at different rates. Okay? So let's see if we can do that. So let's look at the information we are given. Alligator 1, initial weight is 4 pounds. The rate of growth is 1.5 pounds per month. Now, what do you need to do first before you write the equation? Define the variables. Very good. So let the Can we just use X and Y? Yeah? We can just do that, correct? Okay, let's see if we can just stick to that. Yeah, we'll just do 1.5x. Yeah.
You're still on there.
Thank you. Okay. So you can say y equals 1.5x plus 4. And this is going to be the first alligator.
That's not a minus, it's an extra.
Just one. I can use an arrow here. Okay? That's okay. All right. What would be the second alligator?
Y equals
X. No,
Just x plus 6. And this is our second equation. And what are we asked to find? After how many months did the alligators weigh the same amount? Now, both have a different starting point, and they're both growing at different rates, but at some point they're going to be the same weight.
because they have different like,
Yes, correct. Okay? So let's see if we can graph this.
Wait, Kristen said because they have a different slope.
That means they're not parallel.
That's how you know that they're gonna intersect.
Right? Okay. Okay. Better. So what should go on the x-axis?
Their
How many months?
Months. Time goes on the x-axis. And what goes on the y-axis? Size.
Wait.
Weight. Okay. Now what should the scale be? 0.5?
Could be.
Okay, let's try that. So I'm going to say 1 2, 3, 4, and 5.
No,
No,
it's
we're not gonna fit because it's already 6 for one of them.
No, but that's months. But do you
But
really
then
want
we can
half
move
a
it.
month?
For
No,
the X,
that's
it
months.
could be.
Well, that's for the
X is
No,
For the
that's
Y,
a Y.
yeah.
Because
The
it's
Y should
months.
be like
That's
Here I can do 2,
is it time in months?
4,
Yeah.
6, 8, 10, 12, 14, and so on. Okay, yes.
The x-axis should go by 1, like, or by each unit,
Mhm.
1, and then the y should go up by 0.5.
X should go up by 1 and the y should go up by 0.5.
Yeah.
Okay? Alright, why?
No, y can't go up by 0.5.
Because what is the slope here? The rise is 1.5,
To make it easier.
correct? And the run is going to be 1. So it's okay to have 1 unit scale on the x-axis, but you want to account for the 0.5 on the y-axis. So let's change that. So let's do 1, 2, 3, 4, 5, 6, 7, 8, and so on. And here, now remember I have to, the y-intercept is 6. So how am I going to do that?
Each unit is 1, and then you can just do 0.5 in the middle.
Just do that? Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So let's graph the first one. 1.5x plus 4. So I'm going to start at 4. Y-intercept. 1.5 over 1. Somewhere here.
The Y is like
Is that better? Okay. Better? Okay. Okay. Maybe we should change the color.
Make it like yellow. Light mint green.
Hmm?
Mint green. That one. That one.
This one is going to be too light though.
Just can we just see?
No, because of the contrast with the dark blue.
Okay. Okay, let's do the next one. It's different color. What is it? Y-intercept is 6. That's right here. Okay. And what is the slope?
1.
1. So there's 1. The next one. The next one. And the next one.
Intercepted 9 pounds.
Okay.
No, they don't because look, it's in that middle.
Yeah,
The blue line is in the middle, so they intercepted 10.
Right. Okay then.
Wait, why?
Because look, the dot's in the middle of the square. It's not.
Yeah, it's
Don't
actually passed
exactly
through.
that.
This is orange.
They've met, they just haven't intersected.
No, it has to be on the.
Is that one? Is that 8 point?
Yeah, but that's
Give me 1 second. Here. We may have to do a little extrapolation.
Wait,
Okay?
it's
So let's see. Now this point is on the grid. That's on the grid. So next point on the grid is going to be
4,
4, comma
10.
10.
Yeah.
Well,
No, but
isn't that at 10?
intersect to 10.
Or that's like 9.5.
No. Have to intersect.
Let's see.
9.8?
1, 5.5. 2, 7. Correct? 3, 8.5. 4 is going to be 10. So these points are actually intersecting right there. Let me just change the graph just a little bit. So this is here, and this is also there. So the point of intersection is actually right there.
Yeah, that's at 4 months.
Okay?
So 4 months.
So at 4 months, I can say in months. Okay? So at 4 months, both the alligators will be the same weight. Now, how do I prove this?
You plug in.
Okay, so you're going to plug in. So let's rewrite the equation. Why are you talking? Y equals 1.5x plus 4. And let's plug in for 4. So this is our proof.
That would be 4 equals 1.5x 10.
So 4 equals, let's write down the coordinates of the point. 4, comma, 10.
So it would be
Okay.
10 equals
So
1.
10 equals 1.5 times 4 plus 4. 10 equals, what is that? 6 plus 4. So 10 equals 10.
But we have to do the other one.
Let's try the other one also. And we have 10 equals 4 plus 6. 10 equals 10. Again, now this one is 6.
Wait, Paula,
Yes, Livia.
you said that the 10 will always be on the x-axis or the y?
X-axis. Okay. Okay. So let's go over the special types of systems. You can have systems with no solution. Michael, when do systems have no solution? They have the same slope. In other words, they are parallel lines. Now, when you're asked a question, are they always going to give you both the equations in the same form?